Let's talk about one of the biggest, most tantalizing mysteries in astronomy right now. We're talking about a signal, a tiny whisper from the stars that showed up one day, passed every single test for being alien technology, and then just vanished. Forever. This is the story of BLC-1, a genuine ghost in the static.
It's the kind of question that probably keeps astronomers up at night, right? For one brief, incredible moment, it really felt like we had it. The answer to one of the biggest questions humanity has ever asked. But what if the phone rang and we just weren't there to pick it up? Did we just miss a call from our closest cosmic neighbors?
So get this, for just a few hours back in the spring of 2019, a signal came in from Proxima Centauri. And you have to understand why this is such a big deal. Proxima Centauri isn't some random star, it's our closest stellar neighbor. Finding a text signal from there isn't like finding a needle in a cosmic haystack, it's like finding it on your front porch. And for a little while, it looked like the real deal.
All right, so let's rewind. Let's go right back to the beginning, to the moment this mysterious signal first showed up. Our story starts with a little whisper from right next door.
Okay, so picture this. It's the spring of 2019 at the Parkes telescope down in Australia. The team's not even looking for aliens. They're studying solar flares from Proxima Centauri. But suddenly, in the middle of all that cosmic noise, their computers flag something, a super sharp, clean spike. A signal at exactly 982.002 megahertz. It was not at all what they were looking for, but it was absolutely impossible to ignore.
So, what was it about this little spike that got everyone so excited? Well, it wasn't just some random blip. The signal had these characteristics that just screamed technology. There were two big things that made it look completely different from anything you'd find in nature.
Think about it like this. Most natural signals from space are kind of like dropping a huge boulder into a lake. You get this big, messy, chaotic splash that covers a ton of frequencies all at once. But BLC-1? It was like a single, pure note from a tuning fork, a narrow-band signal, laser-focused on one tiny frequency. And here's the thing. Astronomers don't know of a single, natural process that can do that. It's a hallmark of tech.
Now, the second piece of this puzzle is something called Doppler drift. And it's actually a pretty simple idea. You know how when an ambulance siren comes towards you, the pitch gets higher, and as it goes away, it gets lower? That's the Doppler effect. The same exact thing happens with radio waves.
And this is the part that should honestly give you chills. The BLC-1 signal wasn't perfectly steady. Its frequency was slowly drifting. And the way it was drifting, it perfectly matched the mathematical signature of something being broadcast from a planet that was rotating on its axis while orbiting the star Proxima Centauri. It was behaving exactly like you'd expect a signal from an alien world to behave.
Okay, so you've got a signal that looks totally artificial, and it's moving like it's on a planet. The next big question is pretty obvious. Are you sure it's not just, someone's microwave oven down the road? So let's look at the really clever test they used to rule out interference from Earth, a test that BLC-1 passed with flying colors.
It's a simple but totally brilliant move they call nodding. So first they point the giant telescope right at Proxima Centauri. And yep, there it is, the signal at 982 megahertz. Then they move the telescope to point at a random empty patch of sky. Now, if the signal was from Earth, they'd still hear it, right? But BLC-1, it vanished. And the final step, when they aimed back at the star, boom, the signal was back. It was absolutely coming from that one specific spot in the sky. This quote just sums it up perfectly. The signal did everything it was supposed to do if it were real. It was there when they looked, gone when they looked away, and back again when they returned. I mean, at this point, you can just imagine the excitement in the control room was probably off the charts.
But, and this is a huge but, this is where the story takes a really frustrating turn. Right when it seemed like we were on the edge of maybe the biggest discovery in human history, the universe just went silent. Which brings us to the next chapter, the agonizing silence and the desperate hunt for an explanation. And this right here is the whole problem with the BLC-1 case. For science to work, you need to be able to repeat your results. To prove something's real, you have to be able to see it again. But they couldn't. Teams spent thousands and thousands of hours with tons of different telescopes, all just staring at that one spot. And they found nothing. Just silence.
So what happened? Well, the official explanation, which came out 2 years later, basically says it was just a really, really weird case of radio interference from us, here on Earth. They think maybe two separate broken pieces of electronics just happened to create a signal that faked being an alien transmission. But here's the really unsettling problem with that theory. The
The mathematical odds of that happening, of it perfectly faking the Doppler drift of a planet and passing that on-off-on target test are, to put it mildly, astronomically low.
And that's the doubt that just hangs over this whole thing. Officially, the case is closed. It's stamped interference. But there's a huge footnote. They never found the source. There is no smoking gun. No one ever found a broken piece of equipment that could have done it. So they just know it probably wasn't aliens, but they can't actually prove what it was.
So where does that leave us? Let's talk about the frustrating but also totally fascinating legacy of BLC-1. It's still out there, this ghost in the static. It's a story that's both a huge triumph and a total torment for anyone searching for life beyond Earth.
In the end, it all comes down to this number. 1. A single detection. Just one data point.
And like this quote says, a sample size of 1 is the most frustrating number in the universe. And why is that? Because it is just enough to give you this incredible, breathtaking shot of hope. It's enough to make you think, what if? But it is nowhere near enough to give you actual scientific proof. It is the ultimate cosmic cliffhanger. And that leaves us right here with this final, haunting question. We have the data, we have the analysis, but what was it really? Was BLC-1 just a complicated echo from our own noisy, lonely technology here on Earth? Or, for just a few brief hours, did we actually overhear a whisper from the deep dark?